Welcome to day 2 of our 5-day series of Are You Ready for AP Calculus? I'm Eddie. Welcome to the channel. I am doing this for all of you that are curious. What do I have to know in order to succeed and highly achieve in AP Calculus? I'm here to prepare you for that. In today's lesson, we will be covering 5 topics that I believe that are super important for you to have solid knowledge of, foundational knowledge of, for you to know cold heading into AP Calculus. Let's get right into it. Number 1, advanced factoring. The very first thing students think about when they factor is, what multiplied together gives us this number and what added together gives us this number. But don't forget, factoring first came from what do all the terms in the expression have in common? So that's what we're going to do in this very first equation. We recognize that all 3 terms have an e to the x in common. So we factor out that e to the x, we're left with x squared plus x minus 2, and that's equal to 0. This is fairly simple. We can set e to the x equal to 0 and x squared plus x minus 2 equal to 0. But reminder, e to the x never equals 0. So we're done there. On the right side, we have x squared plus x minus 2 is equal to 0. That factors into x plus 2 times x minus 1 equal to 0. So x can be negative 2 or uno. There we have it. Next up, we can use something called substitution. Use substitution. I'm going to call e to the 2x and rewrite it as e to the x squared. Because reminder, whenever we have a power to another power, we can multiply those 2 powers. So now we have, if we set u equal to e to the x, don't forget, we're going to come back to it and solve for x later, we will have u squared minus 6u plus 5 is equal to 0. You'll realize why I'm using the variable u later on in calculus. I can go ahead factor this out, u minus 5 times u minus 1. So u will equal 5 or 1. We're not done. We need to solve for x. E to the x is equal to 5, and e to the x is equal to 1. Well, this one is easy. X has to equal 0 because anything to the 0 power is 1. But for this one, we have to use our logarithmic properties. And we know that the natural log of both sides gets rid of that e, brings down the x as the coefficient of the log. Boom, there we have it. Another thing you'll be working with when you first start working with limits and algebraic limits in your very first couple weeks in AP Calculus is factoring expressions like this. 4 minus x squared, that is a difference of squares. However, it is not x minus 2 times x plus 2. It is 2 minus x times 2 plus x all over. Well, x minus 2 squared is x minus 2 times x minus 2. All this is equal to 4. Keep in mind, x cannot be 2. That's a condition because if x is 2, then we get 0 over 0. That's indeterminate, as you will learn. And the denominator is 0, we can't have that. So 2 minus x, let's see if we can rewrite that. 2 minus x is the same thing as negative x minus 2. So notice these cancel out. Now we are left with a negative 2 plus x. I'm going to multiply both sides by x minus 2, so I get 4 times x minus 2, and this is where the math gets easy. I'm going to go ahead and solve for x. X will equal 6 over 5. There you have it. Advanced factoring, super important. Exponential properties. This should be quite straightforward. I want you to pause the video, check it out. I'm going to go ahead and solve it in 3, 2, 1. Let's get it. I recognize that these 4s can be rewritten with a base of 2. So I'm going to do that. 2 to the x minus 3 times 2 squared to the z minus 2 all over 2 to the 3x plus 5 times 2 squared to the 2x minus 3. When we have a power to another power where the base exponent is nested in parentheses, I can multiply those 2 powers. I'm going to distribute this 2 to both terms, this 2 to both terms as well. So now I have 2 to the x minus 3 times 2 to the 2z minus 4 all over 2 to the 3x plus 5 times 2 to the 4x minus 6. Great. The z is kind of random. That's going to leave itself. But notice how everything is in terms with a base of 2 now. The top ones will add, but the bottom ones we subtract. Ooh, that sounded like a bar. So now, x minus 3x minus 4x. That's negative 6x. Negative 3 minus 4, that's negative 7, minus 5, that's negative 12, plus 6 is negative 6, and we have that plus 2z. Boom. There you have it. This one is even simpler. 3 of these cancel out with 3 of these down here, leaving just 4. 3 of these cancel out with 3 of these down here, leaving just a 2. Don't forget, when we cancel, we're left with a 1. That's the difference between canceling and eliminating. Eliminating makes something into 0, poof in the night. But canceling makes something into 1. So be careful how you use those two words as well. So you have 1 over x squared times x minus 3 to the 4th. Easy peasy, squeeze the lemon. Some more exponential properties here. We're looking for the same base. Whenever you see anything like this, for this first equation, you know that everything can be written as a base 2, or in this case, even base 4. That would actually be easier here, right? Do you notice that 2 squared is 4, and 16 is 4 squared? So we actually have 4 to the power of x plus 1, since this is 1, equal to 4 to the power of 2x. Since the bases are the same, the powers must be equal, therefore x is equal to 1. Wow, that was so satisfying. We also recognize here that 3 squared is 9, so 9 to the x is times 9 to the x is equal to, but this is a little tricky, right? We tried to use that here, but 27 cannot be written as a base of 9. Actually, it kind of can. It'll be 3 cubed. Let's just rewrite it with base 3s. I think this one might be easier writing in base 3. So again, a good mathematician, I wasn't a very good mathematician there, pauses, observes, and looks for a pattern. 3 squared to the x power is what 9 to the x will be, times 3 to the 2x. Looks like those are squared, so we're going to end up getting 3 to the 4x here. 27 is 3 cubed to the 4x, so that's 3 to the 12x. Well, guess what? X just has to be 0, because if 4x is going to equal 12x, the only possible value here is x equal to 0. Logarithmic property, super, super important. If we want to solve for x, what should we do here? I know the natural log has a base e. I can rewrite whatever's inside as the natural log of e to the negative second power, and we know that the power of the argument of the log can be rewritten or brought out as the coefficient of the log. So I have negative 2 times the natural log of e. But what is the natural log of e? This is just uno. So x is equal to negative 2. To solve for x here, I'm going to take the natural log of both sides. So now I have, bring out the negative 2x as the coefficient of the log. ln of e is just 1. I still have natural log of 5 on the right. So x will equal the natural log of 5 divided by negative 2. And you can choose to put that negative out in front on the ln, whatever, as long as you have one negative symbol. That's all that matters here. Okay, let's take a look at this one. 7 to the x is equal to 24x to the x. Again, a good mathematician pauses, observes, and looks for a pattern. In this case, if you went straight ahead and tried to take the logarithm of both sides, yeah, I guess it'll work, but it's even easier than you think. What is the only x value that this will work for? Anything to the power of 0 is 1. So x is actually just equal to 0 here, because 7 to the 0 power is 1, and 24 to the power of 0 is 1. Quite a neat problem here. The unit circle, as I mentioned in day 1, if you weren't there, you can go back to my channel, search up day 1 of 5, Are You Ready for AP Calculus? And you will see me going through all the coordinates, all the components, radians, degrees, coordinates, quadrants, sines, x and y axes. I forgot to notate that. This is the x and this is the y. You can check that out on day 1 of 5 on my channel. And 5, mixing it up. These types of equations you need to be able to solve super quickly and efficiently on the AP Calculus exam and in your class, AP Calculus. Let's check these out. We're going to use substitution again, like we did in our very first advanced factoring slide. E to the 4x plus 4e to the 2x minus 21. Let's see a pattern. Let's look for a pattern. I noticed that there's e to the 2x here. I know that e to the 4x can be rewritten as e to the 2x squared. Aha. So I can say u is equal to e to the 2x, then u squared plus 4u minus 21 will equal 0. Wow, how neat. I'll have u plus 7 times u minus 3. So u will equal negative 7 and positive 3. So now e to the 2x is going to equal negative 7, or e to the 2x is going to equal 3. One thing we know about exponential functions, e to the 2x, for example, it cannot equal a negative number, because if you take a look at the graph, e to the 2x will look something like this. And notice how it never crosses the x-axis down to the negative y values. So this doesn't work. Only this one will work. We take the log, the natural log of both sides, brings out the power of the argument out as the coefficient of the log. And so 2x, let me rewrite it up here, 2x will equal natural log of 3, and x will be natural log of 3 over 2. If you really wanted to go further here, we can rewrite this as 1/2 natural log of 3, and x will equal the natural log of radical 3, since I can move the coefficient of the log back up as the power of the argument. So keep that in mind too, especially in the multiple choice section of the AP Calculus exam. They will do a lot of this manipulation, this algebraic manipulation to throw you off, but you have to know these things cold. So check that out as well. This one is quite simple. U is going to equal log base 2 of x. So I can rewrite this as u squared minus 2u minus 15 equals 0. I mean, this one is even simpler, right? As I already mentioned. U is going to equal 5 or negative 3. Well, if I set log base 2 of x equal to 5 and log base 2 of x equal to negative 3, x is going to equal 2 to the 5th or 2 to the negative 3rd power. 2 to the 5th is 32, and 2 to the negative 3rd power, know your exponential properties, could be rewritten as 1 over 2 cubed or 1 over 8. Quite beautiful. Here's a monster problem. Again, a good mathematician observes, pauses, and looks for a pattern. I noticed that there's a base 4 exponent on the left. I also noticed there's a 4 on the right side of the equation. There must be something we can do there. Let's work with it. Divide both sides by 4, or in other words, multiply both sides by 1/4. But if we multiply both sides by 1/4, do you also recognize that's multiplying both sides by 4 to the negative 1st power? So that's actually what I'm going to do here. I have 4 to the 2x plus 5 times 4 to the negative 1st power. That will give me 7 to the 3x minus 4. All right. I know that when I multiply two exponents with the same base, I can add the powers. That's a pattern that consistently occurs, so we call it an exponential property or rule. So we have 4 to the power of 2x plus 4. That's equal to 7 to the 3x minus 4. We don't have the same base here. So what do? We go ahead and take the logarithm. Take log base 4 of both sides. I usually work and make the base of the log whatever is the base on the left-hand side of the equation. I just gotten used to that. So now I have 2x plus 4 is equal to log base 4 of 7 to the 3x minus 4. All right, well, if I bring down the 3x minus 4 as well, now I have 3x minus 4 times log base 4 of 7. I'm going to go ahead and take all this and distribute it to 3x and the negative 4. This is going to take some more paper, so if you are taking notes here, go ahead, start a new page, maybe go back in the video and restart the problem. We have 2x plus 4. That'll equal 3 log base 4 of 7x minus 4 log base 4 of 7. I need to solve for x. I need to solve for x. I see two terms with an x. I'm going to put those terms on the same side and put every other constant on the right side. So if I bring it back up here, I have 2x minus 3 log base 4 of 7x equal to negative 4 minus 4 log base 4 of 7. Now I have two terms with an x on the left. I can factor out that x And guess what we can do now? It makes me so happy once we get to the end of these types of problems because I get x by itself now. -4 minus 4 log base 4 of 7 all over 2 minus 3 log base 4 of 7. How beautiful. Subscribe if you enjoyed this. Give me a like if it deserved it. Comment down below any questions you may have had, or if you noticed any mistakes. I'm very open to constructive criticism. Let me know in the comments down below. I read every single one. I teach just like this in my courses, by the way. So if you're interested in taking AP Calculus next year, I have a summer course. Check out the link in my bio. And I have a full year course as well. I truly love AP Calculus, and this is what I give my students during the summer and all throughout pre-calculus as well, so you can check those out as well. I hope you enjoyed this. This was only day 2 of 5 of our 5-day series in Are You Ready for AP Calculus? I'll see you in day 3 of 5. See y'all soon.